Hi, it's David Wolpert. I wanted to discuss a little bit about the technology that I'm working on today, which is asymmetric wave functions in sound waves. So one of the technologies one of the systems of math and physics that I was working on is what's called ZFTD. And that stands for Zeta Fractal Temporal Dynamics. And so where it comes from is what's called the Riemann zeta function, and then built from there a quantum charge operator that operates with respect to time as well as space. So the dimensions of the time operators are up for debate, and it's still an area of exploration that I'm looking into. The subsequent technology that I'm building based on that is the idea of using wave functions no longer as just sinusoidal wave functions. And these are things that we're accustomed to seeing all the time, which is asymmetry in wave functions. So in the sound waves that I'm looking at, it's called a ZFTD warp of the sound wave function, such that half of the sound wave is elongated by a different amount of time. So instead of having just a smooth transition, it actually will go down and then up. So the amount of time down and then up, down and then up. So it will have a speed associated with it, where down it goes slow and up it goes fast. And what this does is it allows for the overall energy is conserved, so there's no violations there. However, the total momentum distribution can be different with these types of sound waves. And we have examples of this. So it's a product called the Airzuka. If you've ever heard of it, you have like a sheet and you pull back on an elastic band, and it's got a cone, and you fire it and it shoots out a puff of air. So it's the same concept. It's just working on it in a sound wave sort of fashion. And that's one of the technologies that I'm working on today with respect to fractal dynamics, as well as the behavior of materials and mechanisms with asymmetric systems.